Hey everyone, welcome to homework 12. So in homework 11 we rationalized the denominator with one term. This one we are rationalizing both denominator and numerator, and we're going to have two terms. Again, this is going to be used after calculus. Rationalizing the numerator will actually 100% come up in your calculus class when you are starting off doing limits. And I'll show you exactly what I'm talking about when we get to that problem. But you will need this. So we've already gone over product and quotient rule. The product rule, just to make sure we're on the same page. If you have something like 2 square root 3 times 4 square root 5, make sure you're multiplying outside numbers together and inside numbers together. So 2 times 4 gives me 8. And then square root 3 times square root 15, square root 5 gives you square root 15. Okay, we're going to need that a lot. The quotient rule, I'm honestly not sure if this one's going to come up, but we used the quotient rule in last lesson. Then something else we need to talk about before we can get to rationalizing denominators is like radicals. Like radicals have to have both the same index and the same radicand. So for example, right here, 2 square root 7 plus 3 square root 7. They both have the same index. They're both got a 2 there. And then their radicands are the same. They have a 7 under it. So the number under the radical and whatever that index is has to be the same. Think of this. A lot of people have trouble with this, and they remember to do the 2 plus 3 to get to the 5, but then they will add the square root 7 to make that square root 14, and that is incorrect. Think of that as the same as if you had 2x plus 3x. Those are like terms, right? And they're the like terms because it's also two things. They're the same variable. And what's that exponent? Their exponent's a 1. So you add the number in front, 2 plus 3 to get 5, and then it just stays an x. It doesn't become an x squared, right? That like term carries over with you. So same thing. So if you have something like, well, we'll go over that here in a second. Here's another one. It also works with subtraction. So you have like radicals, you got square root 3x, square root 3x. So you just take those coefficients. 5 minus 7 gets you to that negative 2. So example 1, add or subtract is indicated. You have like radicals. You got square root 5 and square root 5. So that square root 5 gets carried over, right? We're not making that square root 10, square root 5. And then 11 minus 4 gives me 7. A lot of times we kind of mess up on this one. We actually mess up the most on this one because we see square root 17 plus square root 17 and we get square root 34. This is the same thing as whenever you have x plus x. What does that become? That becomes 2x because there's a 1 in front of both of those x's, right? Same thing here. That's the same as 1 square root 17 plus 1 square root 17. 1 plus 1 gives me 2. And C, we have multiple terms. We got 3. Can I add all 3 of those together? Okay, hopefully you said no. And so which 2 are like radicals? Which 2 can I add together? Hopefully you said 10 square root 2 and 5 square root 2. Even though these both have a 5 in front, it's all about that radical. So 10 plus 5 gives me 15. That stays square root 2. And then we just bring down minus 5 square root 3. Okay, and that's all I can do with that. It does also show you right here, not only does that radicand need to be same the index, so one's a square root, one's a cubic root, but we won't run into that problem at all. Okay, so now that we know how to add or subtract, let's get into rationalizing the denominators. So right here, radical expressions that involve the sum or difference of two terms are called conjugates. Okay, that's a big idea in this class and then also going forward. So for example, square root 2 plus square root 5 and square root 2 minus square root 5. That flip of signs is what we're talking about, how one is plus and one is minus. Same thing here. You've got 3 minus square root x and then 3 plus square root x. Those are conjugates. Why conjugates are important for rationalizing the denominator or numerator is because the product of two conjugates will contain no radicals. Okay, and you can see it here with an A or a B. But we'll work some out and we'll see that. And then it says here in radical expressions with a binomial, which means two terms, and the denominator, to rationalize the denominator, multiply numerator and denominator by the conjugate of the denominator. Okay, and again, the process of writing an expression as keyword here, equivalent expressions, they're the same, but without radicals in the denominator is called rationalizing the denominator. So here are your steps with two terms, and they're very similar to one, but it's a little bit different. So step 1, multiply numerator and denominator by the conjugate of the denominator. So whatever that sign is, flip it. Combine like terms. After you multiply, combine like terms. Step 3, make sure all radicals are simplified. And step 4, simplify the fraction if needed. So example 2, rationalize the denominator of the given expression. So we got to figure out what the conjugate is. And here, because we're rationalizing the denominator, we only care about the bottom. So instead of this being 4 minus square root 5, now this becomes 4 plus square root 5. And we're going to do this to the top and to the bottom. And again, what does this right here equal? It's not pretty, but that equals 1, right? If you have the same thing on top as you have on the bottom, that equals 1. So I'm not changing the value of my problem, we're just changing its form. So on the top, I'm not going to multiply that out. I'll do it and I'll show you that they're the same expression, but a lot of times it's easier if you don't distribute that. So I'm going to keep that as square root 3 times 4 plus square root 5 over. How do you multiply two binomials together? You have to FOIL. So I've got 4 times 4, which is 16. 4 times square root 5, it's going to give me a plus 4 square root 5. Negative square root 5 times 4 gives me a minus 4 square root 5. And then negative square root 5 times square root 5 is negative square root 25. Okay, and what's the square root of 25? That's 5. So I'm actually just going to write that as a 5. Okay, remember if you do the multiply the same thing under the radicals, that's just going to come out. Square root x times square root x, that's just x. Square root 21 ab squared times square root 21 ab squared equals 21 ab squared. Okay. All right, so that was step 1, the multiplying. So step 2, combine like terms. On the top, I can't combine anything, so I'm going to make that square root 3 times 4 plus square root 5 all over. In the bottom here, if you notice, you have a positive 4 square root 5 and a negative 4 square root 5. Because those are opposite signs, those are going to cancel out, and that's what's going to happen every single time. That's your difference of squares. So those are gone, and so now all I need to do is combine my like terms here. So 16 minus 5 gives me 11, and that is my answer. Now, if you want to, you can distribute that 3 to everything. So that would be the same as 4 square root 3 plus square root 15 all over 11. Okay, those are both correct. A lot of times when things cancel, it's easier for it to be in this form here, and I'll show you that here on B. Okay, so on B, multiply by the conjugate. So now because this one's a plus, my conjugate is the same thing but with a minus. So I've got 3 square root 2 minus 4 all over 3 square root 2 minus 4. Again, that equals 1, so I'm not changing this. So multiply. Again, I'm not going to multiply out the top, so this is going to stay 2 times 3 square root 2 minus 4 all over. My first 3 square root 2 times 3 square root 2. 3 times 3 is 9. And then the square root of 2 times the square root of 2 is 2. Three square root 2 times a negative 4 gives me a negative 12 square root 2. 4 times 3 square root 2 is a positive 12 square root 2. And then 4 times negative 4 gives me a negative 16. Those middle terms are going to cancel. One is a minus, one is a plus, and so now I can combine. 2 times 9 is 18. 18 minus 16 gives me 2. So I've got 2 times 3 square root 2 minus 4 over 2. And this is why I say it's easier to leave that out, because now I can divide 2 into 2. So those cancel. And now my answer is 3 square root 2 minus 4. So now that we have seen that these middle terms are always going to cancel, let's skip that step. That is why here, when we had the square root of a plus square root b times square root a minus square root b, notice all they did here was multiply these two together and then these two together. They're always going to cancel every single time. Okay, so let's skip that middle step there since we know they're going to cancel out. So on C, we've got two terms in top and bottom. Because I'm rationalizing the denominator, we want the conjugate of the denominator. So I've got square root 5 times square root 3 times square root 5 over square root 3. Again, that equals 1. Not pretty, but it equals 1. So in the top, we are going to have to FOIL again. So square root 6 times square root 5 is square root 30. Square root 6 times square root 3 is square root 18. Square root 2 times square root 5, nope, just 2 times square root 5 is 2 square root 5. And 2 times square root 3 is 2 square root 3. So that's my top. On the bottom, square root 5 times square root 5 is 5. Square root 3 times square root 3 is 3. And because you have minus times positive, that's a minus here. So we can do a little bit of simplifying with this one. Square root 30 does not have a perfect square that goes into it, right? If you break that down, that's 3 times 10. And then 2 times 5. So you don't have a pair of anything that comes out. But square root 18 does. That's 9 times 2. So my top is going to be square root 30 plus 3 square root 2 plus 2 square root 5 plus 2 square root 3. All over 2. Can I combine anything on the top? Because we have a square root 2, a square root 5, and a square root 3, none of those have the same radicands, so we cannot. Another thing to be careful with is you have a 2 on the bottom. You could cancel that out with these 2's here, but 3 is not divisible by 2, and there's a 1 in front here. And so you can't divide anything by 2. So as ugly as this is the answer everybody wants. You might think this one looks a little bit prettier, and I would probably agree with you, but this is your equivalent expression without any radicals in the denominator. Excuse me, I'm so sorry. Okay. In calculus, it is sometimes necessary to rationalize the numerator of a quotient. To do this, multiply by an appropriate expression so that the new numerator contains no radicals. This is technically in proper form. This is technically in proper form. However, like this says, sometimes in calculus, you're going to need to rationalize the numerator. And so it's the exact same process, you're just flipping it. Now you're multiplying the numerator and the denominator by the conjugate of the numerator. Then combine like terms, simplify, simplify. So here, the conjugate of square root x plus 2 is square root x minus 2. And we'll do that in the bottom as well, because what does this equal here? That just equals 1. So now we have a difference of squares on the top. So now I'm just going to do square root x times square root x to get x. And 2 times a negative 2 to get minus 4. On the bottom here, we have 5 times square root x minus 2. I am personally okay with your answer being wrote in this form here. This would be equivalent if you distribute that 5. So x minus 4 all over 5 square root x minus 10. But I like leaving this out because it makes simplifying and doing other things more easy in the long run. Okay, and same thing on B. This is the one that I was telling you about that you will literally need it for calculus. When you start Calc 1, you're going to start with limits. And this isn't going to mean a lot to you now. But here, it would ask something like the limit for whenever x approaches 23. Now, a lot of times when you find limits, all you do is you plug that 23 in. But what happens when you plug in 23 into this one? 23 minus 23 is 0. And so you have some junk on the top divided by 0, and that's a big no-no. So a way to get around that is to rationalize the numerator. So this is a perfect example of exactly when you're going to need that in calculus. So conjugate of the top, since that's what we are rationalizing. You're not changing this sign here. We're changing the sign that's not in that radical. So this stays square root of x minus 22 and becomes plus 1. Square root of x minus 22 plus 1. Again, this equals 1. We're not changing the value. So when you multiply the top, square root of x minus 21 times x minus 21 is x minus, I don't know why I kept saying 21, but you get what I mean, right? Square root of x minus 22 times square root of x minus 22 is x minus 22. Then we've got negative 1 times 1 to give us a minus 1. This is another time when I would not simplify your answer. So instead of distributing this out, this is going to stay as x minus 23 times the square root of x minus 22 plus 1. We can simplify the top. That's going to become x minus 23. Okay, and what do you notice here? We have the same factors. Because these are being multiplied, we can cancel out an x minus 23 on top and bottom because these two here are being multiplied. You can only cancel factors, but they are being multiplied. So then here, my final answer will be 1 over the square root of x minus 22 plus 1. And so going back to what I said originally, if this problem was to find the limit as x goes to 23, well, I couldn't plug it into here because we start dividing by 0, but now I can put that into here. So now we would have 1 over the square root of 23 minus 22 plus 1. 23 minus 22 is 1. Square root 1 is 1. And so my limit here would be 1/2. Okay, so that's how you're going to use this in calculus. All right, that's all I got for this lesson. This lesson has 8 homework problems. So even though it is kind of tedious, right? It's not hard, it's tedious. You don't have a lot of problems to do on this. So that is the one upside. If you have any questions, please let me know. I'll be happy to help. I will be happy to help you out. Could not get that out. Okay, bye guys.